Good morning, students. In today's class session, we are going to be discuss about multi-threading. Before we are going to be discuss about multi-threading, what is meant by a single-threaded and multi-threaded model? Simply, a Java program can support either a single-threaded model or multi-threaded model. Single-thread model means nothing but a single Java program can be started from the beginning and execute a set of statement in the middle and end close in the last. That is, the program are executed from the top to bottom. That means the program execution starts at the top, okay, in the main, and execute the following set of the statements, right? The sequence of the statements. Then after finally it will be ends. Okay, that means a single thread model or a single flow of control. You see the example here. There will be a class ABC, public static void main string args, and the set of statement 1, 2, 3, 4, and 5, and the last will be there. The single thread model, the execution starts at the public static void main. There will be the first execution starts, and the flow of the executions from continuing from the top to the bottom. Statement 1, statement 2, statement 3, statement 4, and statement n. After that, the execution end at the curly braces. Okay, at the last end of the curly braces, right? Okay, this is the single thread model. Okay, in the case of multi-threaded model, a Java program can be divided into subprograms. Okay, a simple Java program can be divided into subprograms. Each subprograms must have a separate sequence of executions. Okay, so you take a program, the main program divided into subprogram 1, subprogram 2, and subprogram 3, like that. So each subprogram 1, subprogram 2, and subprogram 3 must have a separate sequence of flow of control. That means each subprogram must be independently executed, not dependent to each other. Subprogram 1 execute separately, subprogram 2 execute separately, subprogram 3 execute separately. All the subprograms are executed independently to each other. So all the subprograms can be parallelly executed. No need to wait for one program to another. In the case of the single thread model, the flow of the execution, in the case of the statement 1, statement 2, statement 3, the program execution starts at the main, and after that the statements will be executed. It's very important. In the case of multi-threaded model, okay, the subprogram 1, subprogram 2, subprogram 3 all are independently executed. Okay, so we need not to wait for that. Subprogram 2 and subprogram 3 for subprogram 1, and subprogram 2 it does not wait for 3 and 1. Okay, so multiple flow controls are required for that. You see the program, the main program can be divided into, okay, thread A, thread B, and thread C. Okay, so you see the diagram now. That's the class A, public static void main. The programs is divided into, you see here, class A, that is the subprogram 1, and the class B, subprogram 2, and the class C is a subprogram. That means thread 1, thread A, thread B, and thread C, right? So these three threads are parallelly executed. That does not depend to each other. Okay, there must be a context switch appears between the processor. That means switch between the processor level happens, right? So that means a multi-threaded model. A very good example for multi-thread model is human can be doing a job, okay, at more than one time. For example, when he's in office, right, working with the computer, at the same time he's receiving a phone call. Okay, so in this case, the human being can do more than one task at the time. Okay, in the case of the Google Chrome browser, one tab we can download the files okay, animation of file or audio file or video files. In the second tab, I am working with the Java programs. Okay, so you see this is a very good example, a common example for multi-threaded model. Multi-threaded model means a single program can be divided into 2 or more tasks which can be implemented at the same time in parallel. It means a single Java program can be divided into 2 or more subtasks which can be implemented at the same time in parallel. So using this multi-threaded, we can optimal use of CPU resources and okay, memory and everything. When we have multiple CPUs like also, right? So advantages using thread. So threads are lightweight, and that means lightweight means all the programs are stored in the okay single address space. Okay, the single program can be divided into 2 or more subtasks. All the programs are stored into the okay single okay same address space. Okay, single address space or same address space, leading to okay memory will be compacted. Okay, maximize the use of the utilization of the CPU. Always the job will be executing it. So implementing the inter-process communication between the two processes also very fast. Okay, IPC means inter-process communication between the two processes also fast. For example, producer and consumer problems. Okay, so thread also have a life cycle. Okay, so there are the 5 thread life cycle there. One is a newborn, runnable, running, blocked, and dead. Okay, so what in the new state? When we are going to be create a thread for the first time, then it is called a newborn state. Listen, when you are going to be create a thread for the first time in the program, Java program, you are given the statement a equal to new a. You are given as, in this case, that is we can say as a newborn state. Okay, so we are just in the statement we are going to be create a thread. After creating a thread, the thread is okay. We can schedule it run by using the start method or kill it or abort by using the stop method. Okay, so I want to be schedule it to be run. I want to use the start method or kill it by using the stop method. Okay, either I can do for that. Okay, second state will be as runnable state. The thread is ready for the execution. After creating the thread is ready for the execution. So first step is I create a thread. Then after the thread is ready, after creating the thread is ready for the execution. Okay, the thread is ready for the execution, but is waiting for the availability of the processor, right? So the third one, okay, running means the thread is being executed by the processor. Okay, the threading means the point is CPU picks the thread, okay, and that being executed. Okay, so in this case, one of the important point will be used there, that is the yield method are used there. Suppose if the two threads are equal priority, okay, so which one will be executing first? In this case, one of the two things will be happen. That means thread 1 relinks the control to thread 1, thread 2, and you will be execute like that. If the two threads have equal priority now, then both the thread want to be execute. In this case, some rule will be applied, that is first come first serve basis, right? Which thread will come first, that will be executed. Okay, so in the next one, okay, after that running, the thread will be blocked in any of the situations like suspend, sleep, or wait. What will happen then? Now, why the thread is blocked or suspend or sleep, something like? So in the case, there are the two things will be happen. Why? What are the two things, right? So we are executing low priority jobs. In this case, high priority jobs will be coming, right? CPU or given the time slices to high priority jobs only. Okay, suppose the thread CPU, the processor is executing low priority jobs. High priority threads as coming now. In this case, the CPU given the time slices to high priority jobs, right? That is very important. And in this case, the processor asks or simply suspend the low priority thread and pick up the high priority thread and be executed. Okay, so after the high priority jobs will be executed now, what happened that the suspended thread, the processor use a resume method to continue with the operation by using the resume method. Next, suppose we are executing a thread. The said thread is waiting for a particular event. Some operations want to do to perform now something needed for that. In this case, it want to be wait for an IO event, input output event. Input output means this address I want to be read the data. Okay, normally data are stored in the address, or I want to need a printer to perform a something like. So both are not available. What happened to the processor ask the thread to go for some nanoseconds to go for sleep, right? Because for example, sleep 30 means the set thread go for the sleep state for some milliseconds. After that 30 millisecond, automatically the thread okay, wake up and resume its operations. Okay, so the same situations like suppose if the thread is waiting for an input event, or high priority thread is coming, the thread asks the low priority thread to be wait for some time. Okay, to be wait for the some time. Okay, and resume after executing the high priority jobs. Again, the processor call notify method to execute once again. Okay, so this is what okay, the blocked state after all the operations over now, right? The thread is being dead, and the dead state, and it simply it will be using by the use of the stop method. Okay, so this is normally used for simplifying the garbage collection, right? So blocked means not runnable, right? Okay, this is the points we discussed. Okay, so next heading, creating a thread. In Java, a thread can be created in two ways. One concept is by using a thread class. Second one implements runnable. Both the thread class and implements runnable interface, you override run methods, right? You see the diagram now. Both the thread class and the implements runnable using a simply override a run method. Okay, that is in the derived class. So first one, the concept of creating a thread class. Okay, so what are the rules will be applied there? All the steps will be applied there, right? So declare the class. We are going to be declare the class. Okay, and in the class A, we are going to be declare that class should be extended from the thread. So next one, in the class itself, we can use a run method. The run method contains a set of statement that we are going to be executing. Okay, so in the main method, first statement we are going to be creating a thread. After creating a thread, the set thread we want to be schedule it by using the start method. The start method directly call the run method. Okay, so once the schedule method given now, automatically the execution goes to the corresponding run class that contains run method. There will be a set of the statement that will be executed, right? Class A extends thread, right, and the class B extends thread. Okay, you see here class A public and extends a thread, but it contains a run method that contains a set of statements. In this case, we are going to print the value. In the class B, we are going to be print the value, right? J value, class B extends thread, public void run, and then the program itself we have the J value. J value I am going to be printed. Right? So we are going to be create an object, and the A equal to new A, and the B equal to new B. So this is the newborn state. A equal to new A, and the B equal to new B. So newborn state. After creating a thread, I am going to be scheduled by an A dot start and B dot start. Next, by converting a class to the thread, that means implementing interface. So what are the steps there? In this case, first we are going to be using implements runnable. Okay, so declare the class. You see here, class A, I am declaring it that contains the implements runnable interface. Implements runnable interface. Okay, next implement the run method that contains a run method. You see here, it contains run method. Within the run method, it contains a set of statement. The statement want to be executed. Okay, so third one, create a thread, right? And we are going to be create a thread. Within the thread, we are going to be pass the object. Okay, we are going to be pass the object, a thread object that is we are created in the step one. Okay, so third step, we want to be create a thread, and next one we are going to be pass the thread object. Okay, that is created in the step one. Next, call the start method to initiate the thread execution. You see here, class A implements runnable, I1, I3, I'm printing the I value, and the main one, public static void main, create a thread object, right? That's a newborn state, and create a thread. The thread, I want to pass a thread object that is was created in the step 1, and schedule it run by start method. You see here, okay? So that's all the class thing.